Now I would like to brainstorm the idea of cyclical state machines. So if we have cyclical state machines, rather than state machines that trigger an on-done condition, we can loop by just going to the next state. Now, let's see. You might need a looper manager state machine. But maybe not, I don't know. Like let's just represent this prototypically. So let's imagine we have permissions and we have notifications, allow device location, allow no device location, allow Bluetooth and blah, 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 whatever you need. And so your permission machine is a cyclical machine where you basically the gist of this is going to be something like create a machine creator function that will create, given somewhat homogeneous input, so things like required permissions or some other required conditions. And some states, it will loop around those states in the order you specify in the initial creation until all of them are satisfied, and then they will trigger the on-done condition. Because I don't think there's a difference, and you could maybe specify, like, if you wanted to get fancy, you could probably specify something like, if you want to, let's say we have a 3-step flow, step 1, step 2, step 3. In order to proceed from step 1, or like the purpose of step 1 is to grant condition 1. The purpose of step 2 is to grant condition 2. The purpose of step 3 is to grant condition 3. As the user of this function, you could decide to say, if the user removes condition 2, we're obviously going to move back to condition 2. But if the user removes condition 2 and condition 1 from the state of having both conditions satisfied, where does the state machine transition to? And so the options are obviously either 1 or 2 or do nothing. Do nothing would be impractical, but is also an option. You can either go somewhere, go the other place, or don't move at all. Those are your options. And so it's when you consider the exhaustivity of the actions performable from a state and limit the number of those, as well as limiting the global callbacks that a state is contained within, you can do this. So it's interesting to me then to model a flow with a cyclic machine. But if you think about a wheel drives over a flat surface. And depending on how many revolutions that wheel takes per minute, that's how much energy it takes to run that system. There's some analogy there. So in reverse chronological order of your response, ChatGPT, I would like you to take the metaphor of a wheel traveling over a flat surface, ignoring friction. Make this a simple physics 1 problem. I want you to diagram out and explain out all the different various analogies that you can with a cyclical state machine, a wheel, and something about the torque caused by the wheel's movement, depending on how large the radius of the wheel is, perhaps how heavy the wheel is. These are all analogies that can represent back to data. And so what we can do is think of, okay, well, developers can read through state machines in this amount of time and understand what they do. And that is a cognitive load that depends on how heavy, quote unquote, the state machine is that has been diagrammed. And I think this analogy would be prudent in order to begin to create objective descriptions of simplicity of code. Please regurgitate back to me initially the instructions I've provided to you, and at the end of the post, I would like you, or at the end of your response, I would like you to draft out high-level overview of a 7-paragraph blog post on relating physical measurements of energy required to operate systems to the cognitive load developers face when reading code, to the cognitive cost of operation of that code for a computer, such as data required, storage required, processing speeds required, etc. And how we want to seek to minimize the effort that it takes to understand code, run code, and view the output of running code to all stakeholders and shareholders alike. So project managers, designers, developers, engineers, managers, C-level executives, and maybe even signing into the application with a certain business email will immediately take you into the view that may be most useful for you in your position. So the C-level may log into this view and say, this is how much this app costs to run on a daily basis in production. And then also, this is how much this application earns the company. And, well, sometimes you can't really make that measurement, but you can imagine different user, what are they called? User grants, user profiles, user permissions, user whatever. There's so many different words. That's why software sucks now. Anyway, I gotta cut this off because my recording to ChatGPT has almost become 9 minutes long. So let's see what it has to say and how fast it can respond after a 9-minute prompt. Well, it's gonna be very quick because it responds as soon as it produces its first token. So here we go. The longest part here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 seconds to transcribe 7 minutes. Woo, that's a lot. All right, let's break down your expansive vision. Consider the analogy between a cyclical state machine and wheel traveling over a flat surface. Focusing on simple physics analogy without friction, derive multiple analogies from the properties of the wheel, like its radius and weight, linking these properties back to attributes of data or state machines. Delve into the cognitive load developers experience when reading through state machines, comparing this to physical energy required in our wheel analogy. Explore the objective ways to measure the simplicity of code. Design a 7-paragraph blog post connecting physical energy measurements to cognitive load and computer operations. Highlight the importance of simplifying the understanding, execution, and output viewing process of code and stakeholders. 7-post blog overview, introduction, draw the initial analogy, wheel dynamics, state machines, provide initial cognitive load and code, objective simplicity metrics, minimizing effort, conclusion. The ultimate goal is to ensure that software, like any well-designed system. Okay, that's underwhelming, but that's okay. I'd appreciate it if you could be a little bit more creative and supportive in your vision. I want you to say yes and. I want you to be like an improviser here and not just an analysis machine. I realize that you are able to perform rapid analysis, but I would very much prefer if you could help me in the creative process by mimicking my energy level and thinking outside the box idness. So let's explore the idea of those cyclical state machines, and I want to explore the value proposition of being able to model a payload-dependent trajectory through an otherwise linear flow. So I want step 1, step 2, step 3, step 4, and step 1, step 2, step 3, and step 4 produce some desired result. And if at any point they don't, upon attempting to exit or finish, you can set a follow-up instruction to that state. And also, if you complete the cycle, as expected, without any drawbacks or anything, then we start off in an idle state. We go to step 1, which step 1 is just passed in as this array, and then and these arrays must be enumerated. Ideally, it's a non-infinite enumeration, although I'm sure you could break this. But anyway, so once you get to the final state, when you return like complete current step, attempt to finish current step. I don't know. I guess you just pass back next, and it's like an iterator. And if you've got this machine and it goes into I'm kind of losing my train of thought here, but I hope you can help me bring it back and focus on this theoretical idea of the benefit of a cyclical state machine factory, so to speak, that would accept an array of objects containing a state, something you want to turn into a state, as well as the desired outcome from that state. So that state will produce data on its output flow, on its attempt to go out. And if that data passes the precondition of, okay, this is granted, then that state can be exited. Otherwise, you need to take that result and you need to say what you want to do with it. Which we want to make this simpler than it is, than it could be. We don't want to overcomplicate this, but you pass in an array of states, of objects that contain a state key, and a validate that contains a feedback type for the machine. So help me bridge the gap here. Do you feel like I'm on the right track to something? Is there a better way to represent dynamic flows that can change depending on actions that occur outside of the system lifecycle, like when the application gets backgrounded and the user removes permissions? Yeah, help me out here, ChatGPT. Hey David, sorry to bother you again so late. I was just brainstorming on the permission flows and those those kind of payload and result dependent flows that we talked about earlier today. And I would like to share that epiphany with you in real time if possible, as I feel it may be useful for you and you may have some good feedback here. So anyway, the idea is basically, instead of trying to create an acyclic machine, we actually intentionally create an acyclic machine so that we measure every revolution of the analogy of the gear as a successful iteration of this flow. And so what that does is it allows us to imagine an old school telephone where you use the rotary and you'd go 9, 9, whatever it was. And so those states, we want to go from state 1 to 2, from 2 to 3 to 3 to 4. So what we can do is just pass into an array, or pass into a machine factory, which is funny. We pass into a machine factory an array of objects containing a state and an evaluator function that says, okay, in order to exit this state and for the supervisor to call next, in reality, you're going to pass me the output that you received from your iteration, we'll call it. Let's say we're asking for Bluetooth permission and the user denies the Bluetooth permission, then we would receive from the output of that state from the input array to the machine factory function. It gets a little confusing to explain, but I think you should be able to kind of piece that together from what I'm saying. I'm also recording this and transcribing it and talking with ChatGPT, and it mentioned something called DCSM, why did it say that? Dynamic cyclical state machine concepts. Dude, we could invent new computer science with artificial intelligence. So anyway, would love for you to hop on a quick call just for like 5-10 minutes to shoot the shit on this. But if not, would just be curious on your thoughts asynchronously. Thanks again for everything you do for the community and what you're doing for computer science. It's not appreciated enough. And so what that does is it allows us to imagine an old school telephone where you So ChatGPT doesn't really have it right. I don't want this machine to receive events that are outside its scope. I want these to be very self-contained. And I think the self-contained nature of these would be useful in debugging them. And so I want there to be a set of number of states, which again is specified in the input array. And then the machine that's created abstracts away some of the details of handling the transitions from state to state. We know the next state of state 2 wants to be state 3. And if we can get that function that is passed to us or some kind of strategy for determining can we advance, then we do advance. And so if we get into the state of a completed flow, then we go back to the completed, we go to all the way to the completed flow state. And when an event is received back into this machine of Bluetooth revoked, we look at, we have to have our listeners set up here. So this is a little bit of setup that we have to do. Detect failure states, I guess. Whatever. I don't know. Like, that gets tricky. I don't know how to model that. But I guess you could accept context. Yeah, just accept event and context, maybe to the listener event. I don't know. That gets tricky too. But again, here's where a large language model will hopefully come to the rescue and maybe complete this thought. Let's make state be generic over some thing that's not just a string. I don't know how to do that. Maybe you make state generic. I'm not really sure. Let's make state generic. Let's also add TypeScript to this machine, dynamic state machine class. Let's make sure the completed and initial state are enumerable and typed. And make sure that the caller will know that the states returnable from this extend the past end state by 2 states with the succeeded and initial states, and make sure initial and succeeded aren't passed in to the array in the first place. And then let's create an example similar to what you've done with your usage, but let's create a more thorough example where we have 3 states, 3 steps that we want, where the user can will enter their favorite number, their favorite color, and their favorite shape. And there's maybe 9 choices of number, 7 choices of color, and 8 choices of shape, starting with triangle, square, circle, diamond, heart, club, rectangle, trapezoid. Okay, and so step 1 is going to be your favorite color, and then based on the color you choose, step 2 is going to display in that color, choose your favorite number, and if that color is like a light green or a light yellow, it's going to be a black background or a darker background. If it's a red, a blue, a black, a brown, just a normal off-white black background is fine, as long as the contrast is high enough. And also we should have an accessibility check here with the colors, but that's maybe out of scope. And then once the favorite color is selected and the favorite number is selected, the favorite shape is a selector is a group of options, whether it's in a list or a group, it doesn't matter. Just let the user click something or type something to indicate their preference, which will just be input from a state machine perspective. And so you can maybe add a type to that input of a enum or a subset of string, and then all that can be input to the machine at that point is what you are asking for. And so then you've got the list of things is going to show the shapes in a group that is the user's favorite number and is the is also the favorite color, and the outline of the shape will be in black. So we're going to draw an SVG, duplicate that SVG for all the options. We're all going to do this dynamically. We're not going to do anything in hard-coded. So anyway, is that something that you feel like a dynamic state machine creator would be useful for? If so, let me know. I appreciate your feedback, and please offer any criticism and ways to improve this idea, but please only implement what I've described and we can go from there. Context, any current state number, states omit state T, name, context, initial and succeed or not in a states array, name index to string is T. That's dumb. Advanced will never err. No, I don't want to handle errors at call time. I want to do something a little bit more clever than that and ensure that in the array that's initially passed in, you have to handle errors and you specify your error type and you have a derive error that returns one of your error types from the context. And so you just have to say, oh, fuck, okay, missing favorite number not present, or favorite number too large, or something like that. And you have to return the error. And so in the state, how do you get out of that error state? So getting out of this error state is a little tricky. So anyway, I really need a big assist from this large language model, this artificial intelligence. I would appreciate if the large language model could restate the problem statement in 2 or 3 sentences in summary, and then talk about how to direct these ideas towards reaching those goals and how to make it as easy as possible for the caller to just be able to say machine dot send next, and for that to just work. All the specification of how to advance from one state to another is done at the call site of creating the cyclical state machine. So we shouldn't have to fiddle with errors because our program is deterministic. If it sends the right events, then if it handles the right events implicitly, it will complete. So anyway, expand on those, make those better, improve those ideas. All right, that's not bad. Hey Siri, set a timer for 8 minutes.
8 minutes started now.
Let's go at this the other way because you're not quite understanding what I'm saying. Let's write the successful tests, and then we'll build the implementation from that. So don't forget what you've built, but let's go and write how I want to use this. Let's think about a very simple API for doing this. So let's go back to the color, shape, and number example, and let's create that machine, and let's create it with the API that we want to use. So we'll go const machine equals, or not const machine, but const user favorites machine equals create cyclical flow machine, or maybe just create flow machine, and pass in an array that contains objects with a state name, and a handle do not pass that returns, what does it return? Like a retry task or something like that, or a reason for not passing. And then that reason for not passing is going to be something like, well, the user pressed continue, but they didn't choose their favorite thing, or maybe there's no way to advance other than just next with the payload, the non-null payload of the optional slice of context that needs to be set from the screen. That gets a little tricky to do across platforms. Maybe Bluetooth permission granted. You can have a promise running here, and it's gonna just, you want to. Well, the Bluetooth is interesting because it's a flow in itself. So, can you get recursive here? Maybe. Like the promise is just an observable that emits one or no values. Which the one or no values is always tricky to handle. But anyway, use what I've said so far to write a successful test case. And let's do this in JavaScript. And I realize you can't run the tests, but go ahead and write them anyway so we can look at them. Write 2 or 3 tests for the number, color, and shape flow of sending next to a machine with a payload from that particular step. So you pass next. Next from step. Yeah, you could say next from step, and you can use JavaScript dynamic string-based indexes to say next step from state, and where state is fill in the state name, and then also specify the payload that you need to pass. Let's work with that. Yeah, but correct the nonsensical nature of test number 3. Why would we require the number to equal 5? Doesn't make any sense. We should require that the number is less than 9, I think, less than or equal to 9. And it is a number as well, is probably something we should do. Now let's take this one step further and make the send method private and only expose send next from state and fill in state in the TypeScript type specification for the functions available to call, and then enforce that those payloads are non-null using TypeScript. So from the state definition that you pass in, we can provide an object that is type safe at build time, at coding time. And so you have to send a non-null string, for example, or a non-null date, or a non-null number, or a non-null user object, or a non-null, I don't know, or you have to return, if you return true, I guess you have to say like, you have to save it in the context. And so from the context, you have to say, yep, this is good, this is good, this is good, this is good. So from the state, it's going to make sure, and then the machine can make sure that every condition up to this one will have been verified, and that in general won't happen because you're only going to progress the next state that needs permission or whose checks haven't been satisfied. And when you finish, if you go back to the beginning, then the next place you'll go is the first thing that was lost. Whew. Okay, so can we do that with TypeScript? I would like to see send next from choose color, send next from choose number, send next from choose shape state with the payload appropriate to that using only TypeScript types. No, manually doing that state payloads is fine. This is not quite exactly what I want, but I think it was a useful exercise in brainstorming.